Okay, I totally did not just break a small piece and then 3D printed it overnight. Anyway, this is Facklem's Crescent Rose. I'll link the 3D model in the description. This is printed at 205% scale, at about 30% infill, but if you compare it to his video, definitely bulkier and heavier. It's not too heavy, it's approximately 12.2 pounds, but because of the material being PLA, you kind of have to be careful when holding it so that it doesn't, there's not too much stress on all the parts. But anyway, it's very awkward to hold because the material is also very awkward to unfold. Oh, shit. I gotta lay this down. Okay, I think I got it. Watch the tail end. Gosh. See, because the original model, since it's so much smaller, or half the size, it's a quarter of the volume, so it's approximately a quarter of the weight, and because of the sheer weight of all the pieces, makes unfolding it a lot more awkward, but I'm sure I'll figure out a trick. There we go. It's really top heavy. Okay. Okay. God. Yeah, this is not very practical. Try to. No. Okay. I think this is the easiest way to carry it, because there's a lot of stress on these parts. See, this is like this is a good example of how even if a prop weighs only 12 pounds, it can still feel heavy because of how awkward it might be. But yeah, I'm gonna move on to some of the tips I have for 3D printing it. Fuck, this is so heavy. This is so awkward. Okay, first things first. Gotta introduce the thing itself. This is the Thingiverse page created by Facklem. I'm not too sure how to pronounce it properly. But anyway, this is the 3D model developed by the original creator. And to begin, you're going to need a particular set of skills, specifically some knowledge or familiarity with some slicer programs. I would recommend Mesh Mixer for this, or Autodesk Mesh Mixer. It is a free software. Its slicing capabilities are relatively simple. It does not allow you to slice things precisely, something that that Slicer, for example, would be able to do, but it'll work for this project. Anyway, a lot of the 3D printing is relatively straightforward. A lot of the parts you just print as you would. It really depends on your build plate size, for example. Mine has a build plate of 30 centimeters by 30 centimeters by approximately 40 centimeters. It'll really depend on what you have available. For example, the number 6 piece, it is very long, and even with my Anycubic Cobra Plus, if I orient it straight up and down, it's not gonna fit. So I would have to slice it. You could slice a piece like number 6 straight across, and then just edge glue them together. That would be fine as long as you're using something like super glue, for example. Other pieces such as, let's see, number 19, I pretty much sliced it pretty much just before where the boundary of the solid piece and the part that has the slot in it, and then just printed it edge to edge. No, not really edge to edge, where the connecting points are pretty much flat on the build plate, and that way I can just glue them together, make sure they're aligned, and then do a little bit of sanding to make sure that it's all smooth. Another piece like number 22, for example, would be printed straight up and down. I recommend printing it with this side facing the build plate, and it won't be exactly flat, but I would recommend just adding a raft and then printing it at approximately 30 millimeters per second, really slow. That way it will be able to finish without any problems. Other certain pieces like number 16, if I can just pull up Kira, number 16, for example, has to be printed in this orientation. The reason why is because there are slots or grooves on the interior, and you do not want to have any supports gunking that up. Because if you print it in its standard orientation, the supports are going to go up. It's going to get all up in this business, and just it's going to waste a lot of PLA. And because the fittings are so tight, there's like no tolerance at all. You're going to want to avoid as much technical screw-ups as possible. For something like this, I would highly recommend just printing it relatively slowly, 30% infill, 60% supports overhang, I believe. Usually I go with 60% angle, or 60-degree angle, my bad. Zigzag, and then 10% support density, printing everywhere. Anyway, yeah, the rest of it relatively straightforward. Number 24 is a very large piece, very long. I was forced to print it in one piece, 3-dimensionally diagonal on my build plate. If I have a photo, I'll try to share it. Pretty funny. It was a massive use of supports in order to get that done, but it was very necessary in order to get it in one piece. Anyway, with very large pieces, for example, number 41, number 45, a couple of these other large pieces, since this entire project is being printed at 205% scale, it's not going to fit on your 3D printing bed. Not unless you have like a Anycubic Cobra Max or something like that. Even then, it might not fit. So in order to remedy this, what I essentially did is grab the 3D model, threw it into Mesh Mixer,
and then sliced it. So if you take one of the large pieces, for example number 41, and then sliced it in half, you'll see that it's able to fit onto the build plate. But the reason why I have another smaller slice here is because if you can imagine this being one half of the piece and you have the other half, having a straight cut with such little cross section in order to glue the two pieces together, it's just not going to create a very strong bond. So what I do instead is I slice it in half, two pieces, and then I slice it into the original model I slice into thirds, flip it upside down, and then well, I'm sorry, I'm getting ahead of myself. Well, first, the first half, you're going to first reset to 0, and then you're going to lower it, as in go into the Z move, -1.524. You can choose any number as long as it does not, as long as you can get a nice flat piece that's inside the build plate. That way it'll print anything above the build plate, and then it'll leave everything below just non-existent. And so you take this number, whatever negative number you choose. I just chose this number because it's 0.0, I believe 0.06 inches or 0.006 inches. Either way, you take whatever number you choose, you go over to your second piece, you double check the Z dimensions, and then you subtract your whatever negative number you had before in your calculator. Actually, let me just pull it up right now. I'll do it right now. So you take 7.9953 minus 1.524. You take this number, your result, go over here to your third piece, and then you just paste it in, and then there you go. That way the 3D printer will print whatever's above the build plate, aka, or in other words, whatever is not being printed on the large piece. And then you repeat this for all the remaining pieces, and then you just glue the flat surfaces together. This one I'll need to mirror. Then you just glue the flat pieces together, and that way you'll have 1/3 that is overlapping here, then you have another third that overhangs, and then you'll have your other large half piece glued together, and then that way it will create some very strong adhesion, and it'll be a very solid piece. There'll be a little bit of flex, but the direction of stress will not be a problem. Either way, the last thing to keep in mind is that if you check the thing page on Thingiverse, a lot of the comment sections are talking about different scales that you'll be able to print it at, and the screws that will be necessary in order to pretty much secure the pieces together. As you can see, there are some screw holes that the original creator modeled into the original scaling. But when scaled at 205% or 227%, or whatever arbitrary percentage you want to print it at, that's going to be a problem because the holes are going to be scaled up as well. At 205% scale, I used 1024 bolts, I believe, in order to secure the majority of the holes alongside their respective nuts. But certain gear pieces, such as this one right here, I'll go ahead and zoom into it, its hole is just not going to work. You're going to need a very short but also a slightly wider screw or bolt to secure it. And it's really hard to describe without taking pictures, and I was way too focused when actually assembling it in order to record. But if you can imagine the hole just being too big. But yeah, another thing to keep in mind though is that bolts and nuts and screws, the head of them, they take up space. And so if you imagine putting a bolt through this white blade part, having to slide over top of it, it's gonna run into it. And so what I essentially was forced to do was use my soldering iron with a heat knife attachment and carve/melt out a groove or a slot for it to fit over. But that's just something I was forced to do. If you happen to have a different solution to completely avoid that, then it's fine. It's hidden away either way, so who cares? But anyway, yeah, this is a pretty good project to do if you want something really ambitious for a 3D printing project. Would I ever do this again? Probably not, because it's God, it's just so much suffering. But anyway, yeah, pretty fun. Check out the thing page. Hit up the original creator. I'll probably send him a tip pretty soon. But yeah, comment down below if you have any questions. I'll try my best to answer them. Pretty good project. Nice.